Right. Good morning, everyone. You are probably still sleeping at 10 past 6 in the morning, little twits. So I'm up working on a Sunday morning while you guys are sleeping your hindies off. But that's fine. That's fine. You're going to have your work cut out for you. Um, Yesterday, I was sitting here as well at 6 o'clock, and I was going through this 2 hour presentation that I'm going to go through now with you. And I realized afterwards that I never hit the record button. So that is your head of academics of the college for you. Sitting here at 6 o'clock in the morning explaining mathematics to myself, and nobody else is listening. So that was quite a depressing day. But I'm happy to do it again, and I want to talk to those of you who really struggle in mathematics. Those of you who are very anxious and very scared that you're going to fail mathematics, and you've got all these ghosts flying around up in your head. And you probably think that it's too late to do anything about it. Probably think that there's no way to go back. The ship has sailed. You're going to fail mathematics, or you're not going to do well in mathematics. I've got some news for you, and that is that this coming examination is 60% of your entire mark. That means all your tests, everything that you've done during the year, maybe the stuff that you didn't do that well in, that's going to be bundled up into a 40% ball. The examination is going to be 60%. So if you want to make an impression, and I'm saying if you want to make an impression, you still can. There's a reason this presentation is 2 hours long. It's because I'm covering everything again and again that you need to know for your examination. Okay? So I need you to listen very carefully to what I'm going to tell you now. I'm going to give you the recipe for success in the first paper. Now, this is not going to work if you are not willing to work and to meet me halfway. Otherwise, it's not going to work. You can have all the support teachers in the world, the best support teachers in the world. You can have the best teachers at school. If you do not put pen to paper and work, you will never succeed in mathematics. Mathematics is not a spectator sport. You have to be a participant. And it takes a long time. It takes a long time to participate and to practice. But if you don't do it, you cannot expect results. And nobody, no matter how good they are going to be able to get your mark up. You're the only one who can get your mark up. Okay? So that being said, using this presentation now, what I want you to do, it's a 2 hour presentation, but I want you to put pen and paper next to you. And I want you to work. Remember that mathematics consists of two components. The one component is your knowledge, learning your rules and knowing when something is divisible by something else, or what to do when exponents happens and so on. But an even more important part is mechanics. You can listen to what I'm saying and you can watch what I'm doing on the screen. And I promise you, I can give you the same sum 5 minutes later, and you're going to make 2 or 3 mistakes in between. The reason you're doing that is because you think you understand. But if you don't physically go through the mechanics of a sum, you will never be able to see that sum through from beginning to end. There's just no way. You have to put pen to paper. You have to get your hands dirty. If you're not willing to do that, then no one can help you. Okay? So, how are you going to approach this presentation? You're going to have pen and paper next to you. You're going to have a calculator next to you. You can't go to war without a gun, and you can't go to a mathematics class without a calculator. Then I want you, as I go through the presentation, you'll see that all the sums are in black. All the explanations will be in color, highlights, red, blue, and so on. So the moment I go onto a next page, what I want you to do is I want you to write the questions on that page down. And I want you to try it yourself first so that you can see whether you can do it or whether you can't do it. Then you go back to my explanation and you press play again and you consider my explanation. And when that is done, you go back and you do it again. You do not stop until you can do a sum from beginning to end. Then you go on to the next sum. And if you are going to work with me in this way, it means that you're going to be learning the rules, the knowledge part of it, and you're going to be practicing, you're going to be doing the mechanics part of it. So I want you to pause and play and pause and play. and do the sums in between. Okay, don't just sit there and look at what I'm doing. That's not going to help. I've been doing this for 25 years, and you don't want to be in grade 8 for 25 years. So let's get this done. Okay, and then I want you to put all negative thoughts out of your head, and I want you to think positively about the exam that you're going to be writing this week. If you do what I tell you, I promise you, you will do better. Okay, but you need to put pen to paper. You need to practice. Okay, so give me a moment. I'm going to be sharing my screen so that we can get going. Which apparently is not as easy as I thought. Sorry guys, just give me a moment. I'm going to sort this out now. Okay, now that took a while, but let's continue. Let's get to the start of this. We are in for quite a ride, so bear with me and work with me. Okay, so the first thing we're going to do is we're going to be looking at some basics. If your basics are not in place, then you're not going to be able to do any of the algebra that we're looking at. So this is an important page, and I want you to go through it with me. The difference between a plus a and a times a. Let's get a red in here. A plus a, you know, 1a plus 1a, that's going to be 2a. It's like adding apples and apples. Okay, apples, 1 apple plus 1 apple is 2 apples. So if the sort is the same, if the type is the same, remember you can only add like terms. Okay, you can only add like terms. So that you can add. But if you multiply, remember that it's your exponent that's going to become bigger and bigger. Okay, so if you've got something like 2a plus 3a, those are exactly the same sort, so you can apple them. In other words, you can add them. They're both apples. 2 apples plus 3 apples is going to give you 5 apples. An apple plus an apple doesn't give you an apple squared. When you're adding stuff, they stay the same type. Okay, when you're multiplying, then it's going to change. So something like 2a times 3a is going to become 6a, and that becomes a squared. So when you're multiplying, that's going to change. 2a plus 3b stays as it is. You can't do anything there because those are not the same type. Okay, Right, let's take a look at the following two. Extremely important, the difference between these two. When are you going to add your exponents and when are you going to multiply your exponents? And you need to know that. The only time that you're going to multiply is if you've got an exponent outside and an exponent inside. Okay, so in this case, you are going to multiply the exponent outside in with every single exponent inside. So that's going to be a to the power 6. Here we have got two powers with the same base. Remember, the base has to be the same. Then I can add the exponents at the top. Okay, so a squared times a cubed is a5, but a squared to the power 3 is a to the power 6. So if there's an exponent outside the bracket at the top, it gets multiplied in with all the exponents inside the bracket. Right, then this is also extremely important. Sometimes you're sitting with a negative inside the bracket and you don't know if you're going to end up with a negative or with a positive. Now think about it like this. A negative times a negative is a positive. So every two negatives will always give you a positive. So if you've got 100 negatives, it means you've got 50 pairs of negatives, which means it's going to end up being a positive. The moment you've got an uneven number of negatives, like 101, it means there's one negative lying around that's going to be multiplied with all the positives and it's going to become a negative. So if you have a negative inside and that exponent outside is an even number, then that negative is always going to become a positive. You don't even have to think about it. You don't have to prove it in the theorem. You can just remember that. If it's a negative inside and it's odd, it means there's an extra negative out there, which means that my answer is going to be a negative. Okay, this is extremely important to know. Remember, big sums are made up of all the little sums. And if you know the bitty pieces, you're going to know how to do the big pieces. Right, then the square roots. Now we all know that the square root of 16 is equal to 4, because 4 times 4 gives me 16. But the square root of 8 to the power 16, you're not going to take the square root of the 16. If it is an exponent, you divide it by 2. So that becomes 16 divided by 2, and that's 8 to the power 8. The reason is there's a little 2 that they're putting there. They're just not putting it there all the time. Okay, but there is a little 2 that is being placed there. Right. So numbers, you take the square root of. But if you're going to look at exponents, you need to divide by 2. The same with this. The cube root of 8, you know, is going to be 2. But if I want to get the cube root of 8 to the power 9, because it's an exponent, I divide it by 3. So that is going to be a to the power of 3. Right. Let's get to these. Now this is division. Now I know that you can, if the bases are the same, you can subtract the 2. How I like to do it is I try and visualize it. I try and think. If you take a look at a to the power 6 over a to the power 4, that means that there are 6 a's at the top and there are 4 a's at the bottom. So start visualizing, cancelling every single x downstairs out with every a downstairs out with the a at the top. And if you're going to continue doing that, you're going to be left with 2 a's at the top, which means my answer is just going to be a to the power 2. If you look at this one, you can see that it's bottom heavy. There are going to be 2 a's left at the bottom, so it's a to the power 2 at the bottom. Okay? Then 2 to the power 3 is not 6. It is not 6. Neither is 3 squared. It's not 6. You never ever multiply the base with the exponent. 2 to the power 3 is 2 times 2 times 2. So that is going to be 8. Okay, be careful not to make a silly mistake here, especially when you're writing the exam and you're under pressure and so on. Make sure that you don't do this. 2 to the power 3 times 2 to the power 2. There are 2 ways that you can do it. You see that the bases are the same, so you can keep the base the same, and you can basically just add the exponents. And if you're going to work out 2 to the power 5, you're going to get 32. You didn't have to do it that way. You could have said, let's get another color in here. You could have said 2 to the power 3 is 8 times 2 to the power 2 is going to be equal to 4. And 8 times 4 is going to give you that 32. So you could have done it separately as well. Okay, this one, you can see the bases are not the same. So you're going to have to do this separately. 2 to the power 3 is 8, times 3 to the power 2 is 9, and that's going to be 72. This one is also 2 to the power 3 is 8, plus, and that's going to be 9, and that is going to be 17. Okay, so those are basically your basics. I'm just going to turn the screen a bit and make it bigger. But that gives you an idea of your basics. So what I want you to do is pause here and just go through it again and make sure that you understand it. Okay, and if you want to write it down and put pen to paper, then do that. It's the only way that you're going to know for certain that you actually know how to do it. Right, so let's continue. Let's sink our teeth into some questions here. I'm going to make this bigger so that we've got more space. Let me just see if I can. There we go. And let's take a look at the top one over there. So we have got a 4 outside. Now we know that if we've got an exponent outside, the exponent is going to get multiplied in. So that 4 is going to be multiplied with a 3. That 4 is also going to be multiplied with the 2. So we know that we are going to get from the back a b to the power 12. We know we're going to get an a to the power 2 times 4, which is an 8. But this little 2 here, that 2 is a number. It does not get multiplied with an exponent. It gets raised to the power 4. Okay? Remember there's a little 1 over there. So this actually becomes 2 to the power 4, not 2 times 4. So my final answer is going to be 16, and then it's going to be a to the power 8 and b to the power 12. Okay? So don't make a silly mistake like that. It's not 2 times 4. So numbers like this gets raised to that power, but exponents just get multiplied by that exponent on the outside. Right, let's take a look at the second one. Now there's a negative inside here. Now a rule with a negative is that if the outside exponent is an even number, then that negative becomes a plus. But if it's odd, that negative stays a negative. So that's going to stay a negative. Then we've got this 3, which is a number to the power 3. So that's 3 to the power 3, which means 27. So I raised that 3 to the power 3. And then I multiplied in with all the exponents. So that 2, remember there's a little 1 over there as well. So that becomes a to the power 6 and b to the power 6, and that's c to the power 3. Right, next one. Next one, we're just going to multiply out. There are no squares or cubes at the outside of the bracket, so we can just multiply them out. These kissing brackets here means that you need to multiply out. So it's going to be a minus times a minus is a plus. 2 times 3 is a 6. A to the power 2 times a to the power 2 is a to the power 4. And b to the, don't forget that there's a 1 there. B to the power 1 times b to the power 3 is a b to the power 4. Remember that you're adding your exponents now because you are multiplying two powers with the same base. There were the b's as well, b1 times b3. Okay, right, this one, you are going to have to do this one first because this one has got a square on the outside. So the other one can just basically stay where it is. There's a 3 there, so we're going to have to get that in, and then the 2 there, which we're also going to have to go and get in. So if we're going to work this out, this is going to become 2 to the power 3, which is 8, and then a 3 and 3 is 9, and b to the power, that's a b to the power 1, so that's going to be a 3. So that multiplied by, okay? Then the negative becomes a positive. That negative is going to become a positive because there is a 2 outside. And the moment that is even, then it means that whatever the negative inside is going to become a positive. Remember, that's only when it is a negative, okay? Not when it's a positive. When it's a positive, it automatically stays the same. Now this 3 gets raised to the power 2. So that's 3 to the power 2. So that's 9. And then it's a to the power 2 times 2, which is 4, and b to the power 2 times 2, which is 4. And now you can multiply it out. 8 times 9 is 72. A to the power 9 times a to the power 4 is a to the power 9 plus 4. That's 13. And b to the power 7. Right. Okay, if you want to pause and you want to go and do these ones, you're welcome to do that. Otherwise, let's get cracking. Now, here you're just going to cancel out. Now, the top one is going to cancel out nicely. 8 is going to go into there twice. Here you've got 4 x's. There you've got 6 x's, which means there's going to be 2 x's left at the top. There you've got 2 y's and 4 y's, so there's going to be 2 y's left at the top. So my answer is going to be 2x squared y squared over 1, which you can basically just write as 2x squared y squared. Okay, so they cancelled out, or they divided very nicely. The next one is not going to do that. 16 can't be divided by 24, but we can simplify them. We can divide both of them by 8. So 16 divided by 8 is a 2. 24 divided by 8 is a 3. So I'm still going to have a fraction with a 2 at the top and a 3 at the bottom. If you look at your x's, you've got 4 on top and 6 below, so there will be 2 left at the bottom. And then your y's, there's 1 at the bottom and 2 at the top, so that means that there's still going to be 1 left at the top. Okay, do it. Make sure that you can actually do it. Sorry, just needed some coffee there. Right, let's go through to the next page then. Next page, making it a little bit more difficult. And please go through these questions yourself, okay? Write these down, do it yourself, then you come back and you look at what we're doing here. Okay, the first one at the top. Now remember that 64 is a number, so we are simply going to get the square root of 64, which is 8. So we get a square root of a number like normal. But this is an exponent, and that is a base with an exponent as well. And that we're going to divide by 2. So this becomes x to the power 8 divided by 2, which is 4, and y to the power 10 divided by 2, which is 5. And there's my answer. If you know the basics, then nothing can stand in your way. Okay, so square roots, this is important stuff for the examination. Square root, you just divide the exponents by 2. Take a look at the bottom one, that's a cube root. Now the cube root of negative 8 is a negative 2, because negative 2 times negative 2 times negative 2 gives you negative 8. So you take the cube root of negative 8. You don't divide it by 3 or doing anything funky like that, or leave it out. And then you've got x to the power 3 and y to the power 9. Now, because this is cubic, I'm going to divide those by 3. So that's x to the power 3 divided by 3, which is 1, and y to the power 9 divided by 3, which is a 3. Right, then I want to give you an idea of this sum over here. Now, it doesn't matter how difficult we make it. If you stick to the basics, you will get where you need to go. And remember that in mathematics, don't be anxious that you're not getting the first step right. Okay, in this case, for example, there are 2 different ways in which I can do this. Basically, what we're going to do is we're going to work from the inside to the outside. We always simplify on the inside of the bracket, and then we take care of the square outside. So what I'm going to do is I'm going to keep that square there. Then I'm going to start sorting out the inside. Now that's a 16 and an 8. So let's divide it by 2. 16 divided by 2 is 8. 18 divided by 2 is a 9. Okay, so we're going to have an 8 on top still and a 9. X's, there will be 2 x's left at the top, but there will be 2 y's left at the bottom. Okay, I'm doing that quickly because you know how to do that now. You can see x to the power 4 is x to the power 2, so x is top heavy with 2. Y is bottom heavy with 2. Now I cannot do anything more on the inside. Now I square everything inside that bracket. And if I square everything inside that bracket, the 8 becomes a 64 and the 9 becomes 81. And then this becomes x to the power 4 and a y to the power 4. because I'm going to take that exponent and I'm going to multiply it in with every single exponent inside. But this number and this number gets raised to the power 2. Okay, if you didn't get it right, go back and do it again and again and again until you get it right. Remember, every sum that you do is a blueprint for the one that you're going to get. So even if you do the same sum 10 times, you're practicing mechanics. Okay? Right, this one. A lot of work at this one here. Okay, but you know your basics, so let's take a look. Let's take a look at this one first here. The square root of 100 is 10. The square root of x to the power 100 is x to the power 100 divided by 2. So that is 50. Okay, so that's the first one over there. The next one. There's a negative inside the bracket, but there's a cubic outside. So that negative stays in negative. The 2 gets raised to the power 3. So that's 2 to the power 3. So that's going to be 8. And then that exponent gets multiplied to this exponent. So this is x to the power 12. Okay, take it step by step. Okay, don't be worried about using too many steps or whatever. Take it step by step, however much you need. This is 2 squared, which is 4 times 5. So that's going to be 20. And then here, that's x to the power 1. So the 2 just gets multiplied in there. So it's going to be x to the power 2 and y to the power 8. Right, so let's get one answer on top, one answer below, and then we divide. That's usually how we do it. Don't start dividing now. You can, but let's simplify on top, simplify below, and then we cancel. So on top, I'm going to get 10 times minus 8, so that's minus 80. And that's going to be x to the power 62. Okay, and at the bottom, I am going to have my 20 x to the power 2, y to the power 8. Right. Now, a negative divided by a positive is a negative, and there's going to be a 4 over there, because 80 divided by 20 is a 4. Look at your x's. You've got 62 x's on top and only 2 below. So that means that when the dust settles, you're going to have 60 left at the top. But there's still a y to the power 8 that is going to be at the bottom. Not a difficult question. All you do is you just follow your rules. That's all it is. Okay, this page is extremely important. When we had a question like the top on there, 24a6b squared, you can see there are no pluses or minuses in between here. So what we would do here is we would basically just cancel out. So I would get an answer of 4, a6 and a2, that would be a to the power 4, and that would be a b. Okay, there were no pluses or minuses there. But now I want you to look at the bottom 2 that I've got here. There's a plus in between. There's a minus in between. And you have to know exactly how to do these questions. What you cannot do is you cannot cancel out the 2a to the power 4 with either one of those. Okay? Because there's a plus sign in between, it means that both of these are going to be divided by the bottom one. Okay? So let's do this step by step. So both of them, let's take 24a to the power 6 divided by 2a to the power 4. 24 divided by 2 is 12. A to the power 6 divided by a to the power 4, that means that we're going to have 2 a's left on top, plus. Then we've got this one here that we have to divide by 2a to the power 4. 18 divided by 2 is 9. A to the power 4 divided by a to the power 4, they cancel out completely, and that means that there's a 1 left. So this is my final answer for that question. Okay, looks like a difficult question. And when you are in the exam, it is going to be a difficult question if you don't know what to do. If you know what to do, then it's actually going to be extremely easy. So you need to know that in the examination, if you're going to see a sum like this, where it looks like it's the right thing to cancel out, but you've got negatives and pluses in between, you have to do them separately. Okay, the following two are extremely important. This one exactly the same. You can see there's a negative in between. So we're going to divide those two and then divide those two. But be careful of your signs. It is important that you remember to divide your signs as well. Okay, so let's take this one divided by this one. And if we're going to do that, negative divided by negative is a plus. 18 divided by 6 is a 3. A cubed over a squared, there will be a left. And b4 over b squared, there will be b2 left. Okay. Now, we're going to take a look at this one over this one. And if we're going to do that, be careful of the signs. This is a negative here, and that's divided by a negative there. And that means that becomes a plus as well. So don't throw your signs away. You have to divide your signs as well. 24 divided by 6 is 4. A6 over a squared is a to the power 4. And then, of course, b squared over b squared is 1. It's like dividing 2 by 2 or 4 by 4. Okay, it's always 1. So b squared over b squared is 1. And that is my final answer. Big, impressive, difficult question. But if you know what to do there, then you actually have a few marks in the pocket here. Right, the bottom one. Now here, we need a red. You're going to do exactly the same. You're going to, because there's a minus there, you're going to do this one divided by this one, and this one divided by this one. There as well, that one divided by that one, and that one divided by this one. Okay, just going to do them separately. So when you do this one, you're going to get 2x squared over 2x, so there's going to be x left there, minus 4 divided by 2 is a 2, and x divided by x is a 1. Now, the catch here, and this is important. That minus there, remember, belongs to the whole term. So if you write the following down, you are going to be wrong. So what people are going to do is they're going to put the minus there. Then they're going to say x squared over x, so there's an x left, minus and 2x over x, there's just going to be a 2 left. And that is wrong. That is wrong. And the reason it's wrong is because that minus there actually belongs to the whole one. So you should keep this in brackets. So you simplify that first, and then you bring the minus in. Okay, and that is important to understand. So you're going to get here x minus 2. Now the minus comes in, minus x, and that becomes a minus times a plus 2, a minus times a minus 2, and that is a plus 2. So my answer is going to be 0. So it's important to remember that you have to take this first and simplify it first, and that minus belongs to both of those solutions. Okay, this is a very important question that you need to take a look at. Right, let's move over to the next one. We're going to take a look at a bit of integers. Negative 2 plus 6 minus 4. You are just happily walking around on the number line. There are no multiplications or anything there. So you're standing at 0, you go 2 to the left, then you walk 6 to the right, and then you go 4 to the left again. And of course, if you're going to do that, you're just going to end up smack dab at 0 again. Okay, but there's no multiplication there. Here we've got multiplication because we've got a bracket times a bracket. And we know that a negative times a negative is a positive, and 2 times 6 is 12. Remember that minus times a minus is a plus. Plus times a plus is a plus. Plus times a minus is a minus, and so forth. Okay, now here, look at that negative over here. See that this negative 2 doesn't have anything to do with the bracket. It is actually completely separate from the bracket. The way to get the bracket away is to take the sign just in front of it and multiply the sign in. So the negative 2 stays where it is. Don't multiply it with a negative 6. There's no multiplication sign here at the beginning. There's no multiplication sign there. So that becomes a minus times a minus is a plus 6. And then that is going to be a plus 4. Okay? So the negative 2 doesn't get multiplied in. But if you take a look at the bottom one here, you can see that the sign in between there must be a multiplication there. There's no sign in between the 2 and the negative 3. So there, you're going to have to multiply it in. Okay, one thing that you cannot do at this one is you cannot say 4 minus 2 is 2, and then I need to multiply it by -3. If you're going to do that, Botmas is going to visit you at night and is going to strangle you at night. Okay, because you're breaking his rule. You're not allowed to do that, because what you're doing is you're actually doing subtraction before multiplication. And you have to do your brackets first. So you have to do that and this before you start adding and subtracting. So this 4 doesn't have anything to do with the rest of the brackets. So it just happily stays at the front there. Then I've got -2 times a -3. That's a plus 6. Then we multiply that negative in, so it becomes a plus 4. Then we multiply the plus with a minus, it becomes a minus 6. And my answer is eventually going to be 8. Right, so bottomless comes first. Here as well. Here I'm going to have to do the brackets first, so I do that, and I need to do this. But here I'm going to have to do that whole bracket there. So I'm going to multiply this out first, and then I'm going to multiply the minus in. Okay, one thing at a time. So let's multiply this out. This is going to become negative times a negative is a positive, 6ab minus. Now, let's multiply that out first. Minus times a minus is a plus. 4 times 6 is a 24, and a to the power 1 times a is a squared, and that is going to be a b. Now I can multiply that in. So this becomes 6ab, and then it's going to be minus 24a squared b. And you cannot add or subtract those, because you can see the letters are not the same. That's AB over there, that's A squared B. So those are not like terms. So you cannot add or subtract them, so you leave it like it is. What is important here is that you have to do the brackets here first, and then the negative comes in. Okay? You always do all the brackets first. Right, let's carry on. Let's see what we've got here. Okay, just a little bit of practice. So if you take a look at this one here, at the top here, let's take a look at this. That's -2, and then that is just going to be AB. The square root of A squared B squared is just AB. Then we've got a minus, and of course we know now that we're going to do the brackets first. So this we do first. And a minus times a minus is a plus. 2 times 3 is a 6, and A times B is a B. Okay, now I'm going to get -2ab, and now I can multiply that in, so it becomes a minus 6ab. And what do you know? Those are like terms. Okay, and if they're like terms, then -2 of them, -6 of them is going to give me -8 of them. Remember, the terms stay exactly the same. It doesn't become a squared b squared. If you add or subtract, terms stay exactly the same. It's only when you multiply that is going to become squares and cubes and so on. Okay, let me just take a sip of coffee again. Right, now, here at the bottom. Are you going to get this? Bet your bottom dollar you're going to get this. So what you're going to have now is you've got more than one term inside the bracket. You can see there's a plus in between. So you've got 2 terms inside the bracket. And this 2 is supposed to be multiplied to the bracket. Now the rule is that you take that 2 and you multiply it with every single term inside the bracket. So that 2 gets multiplied to the a, and it gets multiplied to the 2. So 2 times a is going to be 2a, and then plus 2 times 2 is going to be 4. Okay, sometimes what people do is they multiply the 2 with the a, and they just write 2a plus 2. So they forget to multiply the 2 with the last one as well. You have to multiply whatever gets multiplied into the brackets with every single term inside the bracket. Okay. In the bottom one here, you can see that there's still a multiplication in between there. So that 2 is also going to be multiplied in the same as it was at the top. So it's still going to be 2a plus 4. Whether it's 2 times the bracket or bracket times 2, it doesn't matter. You're going to get exactly the same answer. Okay, now listen carefully. At multiplication, it doesn't matter in which order you multiply things. Think about it. If I've got 1 times 2 times 3, I'm going to get the same as 2 times 3 times 1, and I'm going to get the same as 1 times 3 times 2, or 3 times 1 times 2. It doesn't matter what the order is in which I multiply it. Now, if you take a look at the sum that we have here, there's a 2 that wants to get multiplied in, and there's a 3, and both of them wants to be multiplied into the bracket. Now, if I get a question like this, it doesn't matter in which order you multiply it. So what I would do first is I would multiply these two first and get a 6, and then I multiply it inside with my bracket. See what I'm doing? I'm multiplying the 2 and the 3 first, getting a number, 6, and now I can multiply that into the bracket, so it becomes 6a plus 18. Now, you don't have to do it that way. I promise you it's the safest way of doing it, because you're going to end up multiplying in, and you're going to be doing it wrongly. Okay, the difference between... There you've got kissing brackets. That means multiplication. So here they want to multiply the minus 2 in, and they want to multiply the minus 3 in. Okay, so what we're going to do is we're going to multiply the numbers first. Negative 2 times the negative 6, negative 2 times the negative 3 gives me a plus 6, and then we're going to multiply it into the bracket. So the bracket we multiply last. And then I multiply the 6 in there, so that's going to become 6a plus 36. But look at the bottom one. Look what happens with this negative 3 at the back there. That negative 3 is not going to be multiplied in. It's only the minus 2 that gets multiplied in. That 3 is separate from the bracket. It doesn't have anything to do with the bracket. The moment I put a bracket around it, like here at the top, then it's going to get multiplied in. But there it's separate. The negative there means that this is actually a separate term. So I'm just going to keep this negative 3 at the back. I'm not going to do anything to it. I'm not going to multiply it in, nothing. But I am going to multiply the negative 2 in. So negative 2 times a is negative 2a. And then negative 2 times plus 6. Remember to multiply the minus in as well. That 2 doesn't mean anything without the minus. So you have to multiply the whole minus 2 in with a whole plus 6. So that becomes minus 6. Minus 12. What can I say? It is nearly 7 o'clock. Minus, and that's going to be 12. And then your final answer is going to be negative 2a, and that is going to be negative 15. Okay, try it yourself. Make sure that you can do it. And don't stop until you get it right. Okay, so what I've got here is I've got two sums that are a little bit bigger and a little bit more difficult. Now, you're not going to get sums like this because it is going to be too much work. But these sums have got different elements in that you need to be able to do. Once again, remember that you can't say 10 minus 2 is 8, okay? Because BODMAS is going to strangle you. You cannot do that. You first have to do the brackets. So you're first going to do all the brackets. That's a bracket a plus 1. And there's a negative 4. There's a bracket at the back there. So this 10 is just going to stay at the front. So you're going to have 10. And then here what's going to happen is the minus 2 is the only one getting multiplied in. So you multiply it in. But be careful. Remember your minus 2. Minus 2 times 2a is minus 4a. Then minus 2 times minus 1 is going to be plus 2. Here there's a negative 1. So we're just going to multiply that in. So it's going to become negative 1a, and a negative 1 times a plus 1 is a negative. Look at this negative 3. This negative 3 does not belong to any of the two brackets on either side of it. It's loose. It's a completely separate term. But here what we've got on this side is that the negative 4 wants to get multiplied in, and the 2 wants to get multiplied in. But you know now what to do. If you've got two numbers that needs to get multiplied into the bracket, multiply the numbers first. Okay, so I'm going to take the -4 and multiply it by the 2 first. -4 times the 2, so that becomes -8, and then there's the bracket a minus 2. Right, let's simplify here a bit. We've got -4a minus a, so that's minus 5a already. And then I've got 10 plus 2, that's 12, minus 1 is 11, minus 3 is going to be 8. And now I multiply the minus 8 in there, so I get minus 8a, and then minus 8 times minus 2 becomes a plus 16. You can see that if you did not multiply in the negative there with that negative over there, you would not have gotten the plus. So make sure of your signs. And then we end this up -5a, -8a. That is going to be -13a, and plus 8 plus 16 is going to be plus 24. There we go. Right, this one we're going to have to do brackets first, so we have to do that, and we have to do that. There we're only going to have the 2 that gets multiplied in, but here we've got both of them coming in there again. So let's multiply these two first. That's going to be minus 15a. That still needs to be multiplied in with the a minus 2, and then the rest. Okay, so let's do that. So if I multiply it in, now be careful of this negative here. So negative 15a times a is negative 15a squared. Then I've got negative 15a times a negative 2, so that's a plus 30a. Right, and then I've got the negative 4a squared, which is loose, and then I multiply the 2 in, so that becomes a plus 2 minus 2a. And the moment you're there, it simply becomes a case of getting your types sorted out. There's negative 15a squared, negative 4a squared, so that's negative 19a squared. Then I've got the 30a there, minus the 2a, so that is plus 28a, and then plus 2. And there's your answer. It's not difficult. If you think it's difficult, go and do it again and again and again until it gets easier and you can actually do it. Okay, put pen to paper. Put in some elbow grease there. Right, let's go on with the next one. Remember, you can stop at any time. This is just a little refresher of something that we've done already to see if you can actually do it. So if I were you, what I would do is I would actually pause now and I would try this one on my own. But of course, you've listened when we were doing this, and you know that we're going to do this separately. We're going to take that and divide it by this, and this and divide it by this, because of this big fat plus that's in between here. So this is going to be, so we are going to be taking this minus 18a5, and we're going to divide it by this. So minus divided by plus is a minus. 18 divided by 6 is a 3. a5 over a2, so that's a a3. b4 over b2, so that's a b2. Then we're going to have this plus 12a, and we're going to divide that by this now. And if we're going to do that, we're going to get a plus divided by a plus is still a plus. 12 divided by 6 is a 2. a4 on top, a2 below, so that's a 2a left. And b squared over b squared is a 1. So that is my final answer. Okay? And that is easy. It's not difficult. It really isn't difficult. The moment you know what to do, the moment you know that you have to take this and divide it by that and that divide by this to do it separately, then you'll be fine. It's just a question of doing enough so that you can actually remember that. Right, Old Faithful. These type of questions. Now I've put 2 of these questions in on this page and on the next page because they are important. They are always being asked in exams, and I promise you, you're going to get questions like this in this coming exam. So you've got one of 2 choices at this point in time. Either you ignore it, or you actually work and you get the 7, 8 marks for this question. Okay, so let's go through this very carefully and make sure that you understand. Okay, so you're given a polynomial. A polynomial is just an expression with a lot of terms. And you can see that in this polynomial, we have got 1, 2, 3, 4 terms. So if they ask us how many terms are there, we can say that there are 4 terms. Okay, the constant term is the term without an x, and that is the -6. It is not 6. If you write down 6, they're going to mark it incorrect. Okay, it is -6. Remember the sign in front of the negative, in front of the 6. Right, then here they ask the coefficient of x to the power 4. Now, if you take a look at this, you can see that there is no term with an x to the power 4. No, there's an x to the power 2. There we go. And we've got an x to the power 3 and an x to the power 1, but we don't have an x to the power 4. That means that that is a coefficient of 0, because it was probably 0 times x to the power 4, which was 0, so it was left out of the polynomial. So if it doesn't appear there, it means that that coefficient is 0. And on the other hand, the coefficient of x to the power 3, now there's x to the power 3, so that coefficient is going to be the number in front of it, so that's going to be -6. Okay, if you take a look at the coefficient of x squared, that will be a +4. The coefficient of x, that would be a -1. Okay, so the coefficient is the number in front of it. Right, then the degree. Now, to find out the degree, what you do is you take a look at all your powers. Remember, there's a power 1 there. And the highest power gives me my degree. So the degree of this polynomial is 3, because my highest is this 3. My highest exponent is that 3 over there. So that degree is just going to be 3. Okay? Not difficult. Not difficult at all. You just need to remember it. That's it. Okay, then they want us to write it in descending order. Now remember the difference between ascending and descending. Think about a mountain. If you go up a mountain, it means you ascend a mountain. So you go from small to large. Okay, and we're talking, when we talk about small and large, we're talking about the powers in the terms. Descending means we're going down. So if we have to put it in descending order, we're first going to take the term with the highest power of x, and we're going to end up with the lowest power of x, which is your constant. So if I have to put this in descending order, it is going to be first -6x to the power 3. Don't forget the negative. Then it's going to be +4x squared. And then -1x. And then it's going to be -6. That's descending order. Ascending order would be the other way around. Right. Okay, in this question, find the value of the polynomial if x is equal to -2. This is substitution. What they want you to do is they want to make all your x's -2's. So you take that polynomial just as it is, and everywhere you get an x, you're going to put a -2. You don't change anything else. So everywhere there's an x, you put a -2. That's to the power 3 minus 1, and that's a -2 over there. You can see that I'm putting the -2 in brackets. Whenever I substitute, if they give me numbers to put into a polynomial, I always use brackets. And then, of course, I need to do my brackets first. So I'm going to have to do that first, and that first, and so on. I cannot, for example, multiply this 4n if there's still a square there. That square locks the bracket. So I need to do that first. Okay, so what I'm going to do, let me just get that gone. We're going to have this -6 stays where it is. It doesn't have anything to do with that. This is going to be +4, and then -2 squared is -2 times -2, so that's going to be a 4. Minus 6, and that's a -2 to the power 3. So it stays a negative, and 2 to the power 3 is 8. And here I can multiply those in. Minus 1 times minus 2 is going to be a plus 2. Right, so now I get negative 6 plus 4 times 4 is 16. Negative 6 times negative 8 is going to be plus 48. And then that is going to be plus 2. Okay, and you can work out your answer there. Okay, I want you to take this question. I want you to go and do this question again. Okay, you will definitely get a question like this. I don't know what your examination paper looks like at the moment, but I can promise you that you're going to get this question. Okay, another way that they can ask this question, if you take a look on your screen now, you're going to see something very strange, and that is that your polynomial now has got x's and y's combined. If you take a look there and you take a look over there. Okay, now you're still going to have 1, 2, 3, 4 terms, but what you're going to have now is your degree is going to be different. If you take a look at your degree, that 2 there means it's second degree, but when you've got an x and a y, they together give you the degree. So the degree of that term is a 2. The degree of this term here, there's a 2 and a 4. So that degree is a 6. So if there's an x and a y in there, the degree is given by the sum of the two exponents. Okay, let's take a look. Number of terms, we've still got 4. Degree, it's a 6 degree. Okay, so we don't just look at x, we look at the x and the y. X squared, y squared, and the 2 and the 4 gives me 6, so that's a 6 degree polynomial. The constant term is going to be this negative 4. So nothing's changed there. The coefficient of y. Now here you have to be very, very careful. If you write down this term minus 2xy, the coefficient of y is everything in front of the y. Okay, or let's say in that term it's everything else, which means that the coefficient of y is not going to be just minus 2, it's going to be minus 2x. Be careful, be careful, be careful. If they asked you what the coefficient of x would be, it would be negative 2y. So everything else except for x. Okay, so the coefficient of y is going to be negative 2x. The coefficient of x to the power 3. Now let's see. X to the power 3, we don't have a term with x to the power 3, so of course that's going to be nothing. Okay, now let's just stand still here a bit. Let me get this in red. Let's say that you've got that term over there. Now that term over there is 6x squared y to the power 4. And if you take a look at that, and if they ask you the coefficient of y to the power 4, it would be 6x squared. Okay, but let's say that they asked you the coefficient of x squared. What you're going to do then is you're going to rewrite that and just pop that around so that the x squared is at the back. And if you do that, it means that your coefficient of x squared is going to be 6y to the power 4. Okay, so it's a little bit more difficult than usual. So the term was 6x squared y to the power 4. So we know that the coefficient of y to the power 4 will be 6x squared. But if they specifically ask the coefficient of x squared, write your x squared at the back, then everything else in front of it, that is going to be your coefficient of x squared. Okay, then the last question, x is equal to negative 1 and y is equal to 2. So now we just have to pop it in there again. So x squared, so that's negative 1 squared minus 2. X is a negative 1. Y is a 2 plus 6. X is a negative 1 squared, and then y, which is 2 to the power 4, and then negative 4. Okay, so there you've substituted everything. Let's just bring it a little bit closer. And now I have to work this out, but remember that you have to do your brackets first. Nah? So you're going to do that first, you're going to do that bit first, that whole bit there as well. So negative 1 squared is just going to be a 1. Here I'm going to have negative 2, and then there I'm going to have negative 1 times 2, so that's a negative 2. Plus 6, and negative 1 squared. Now negative 1 squared is going to give me a 1. And 2 to the power 4 is going to give me a 16. So that means that I've got a 16 left inside the bracket there, minus 4. So this first, so that gives me a 1. And that is going to give me a 2 to the power 4, so that is a 16. And now I can multiply the negative 2 times the negative 2 is a plus 4, and that's going to be a plus 96, and that's going to be a negative 4, and you can work out whatever that is going to be on your calculator. Right, let's see what we've got next. Okay, it's just a little bit of revision, so let's get to this. And you can write it down first and you can try it. Let's just sort that out. That is supposed to be square there and a minus there. And then I can't remember what this was originally. Let's make this 8. Doesn't really matter. Now, when you add or subtract fractions, terms, you have to make sure that your terms are the same. And if you look at this, you can see the only terms that are the same is this one here and this one here. All the other terms are actually not the same. 16a squared b squared. There's ab squared, and then the last one is a squared b. So you can only add the ones that I like. So 16a squared b squared stays where it is. These two I can add. Negative 8 plus 4, so that's going to be negative 4 of ab squared. Nothing changes there. The type stays the same. And then plus 2, and that's going to be a squared b. Okay, just a little bit of revision. Here's another one. Looks complicated, but what's going to happen is that's just going to get multiplied in with every single term inside. Just because it looks more complicated doesn't mean that the basics are out the window. Okay, so you've got one term at the front that needs to be multiplied in with two terms there. Just be careful of your signs. Here I've got a minus that needs to be multiplied by a minus, that becomes a plus. 4 times 3 is a 12. X squared times x to the power 1 is x to the power 3. And y to the power 1 times y to the power 2 is y to the power 3. Okay, now be careful. Multiply this whole term with that whole term there at the back now. So minus times a minus, don't forget your signs, is a plus. 4 times 2 is a 8. X to the power 2 times x to the power 2 is x to the power 4. Y to the power 1 times y to the power 1 is a y to the power 2. And of course, those I can't add. They're not like terms, so I leave them exactly as they are. Okay, these questions, just taking a look at a bit of basics. You can do it in two ways. One way is you can see that the bases are the same. So you can write the one base and then just add the exponents. So this becomes 2 to the power 10. And if you're going to look that up, that's going to be 1024. Or you can do it separately. So you can say 2 to the power 8 and actually work it out. Multiplied by 2 to the power 2, and you're going to end up getting exactly the same answer. So you could have done it separately as well. Okay, the same with the bottom one. With the bottom one as well, you can do them separately or the same. So in other words, you could have said, well, 2 to the power 8 is 2, 5, 6, and 2 to the power 2 is 4. And then you could get your answer. Or what you could do is, because if you take a look at it, you've got 2 2's at the bottom and 8 2's at the top, which means that if you're going to start cancelling them out, it's going to be 2 to the power 6 left. And 2 to the power 6 is 64. There you would have also gotten 64. Remember what I said. In mathematics, there's always more than one way to get your answer. So don't be scared of doing something because you think it's going to be wrong. As long as you're going to follow your basics, you're not going to have a problem. Right, let's see what else we've got here. Okay, now we're starting with equations. Okay, remember that you can stop at any time if you want to. Equations, if we get equations, and you will get equations, you just need to get your x's to one side and your numbers to another side. The thing here is you have to be very careful that the moment any of those numbers go over the equal sign, the sign is going to change. So here you're going to get 4x on this side. I usually take everything over to the left-hand side. The negative 2x comes over, so it becomes a plus 2x. On the other side, I've already got the 2. The negative 6 comes over, it's a plus 6. Do not forget to change your signs. People forget to change their signs, and then the sum is wrong. So this is going to be 6x equal to, and that side is going to be equal to 8. Okay, now I want to get x, so I'm going to divide by 6 here, and I'm going to divide by 6 here. So x is going to be equal to 8 over 6, which is the same as 4 over 3, which is the same as 1 1/3. Right, so that you possibly can do, and you've done that already. Let's take a look at something like this. Now all that happens here is that you've just got brackets, so you just have to get rid of the brackets. Be careful here. Be careful here. Remember, you're going to do brackets first. Don't say 4 minus 3 is 1 and then multiply it in. Okay? Botmas is going to be very angry if you do that. Here as well, the negative 4 doesn't have anything to do with the bracket. It doesn't get multiplied into the bracket. So it's only the negative 2 that gets multiplied in. So this is going to be negative 2x, negative 4, and then that negative 4 comes at the back, 4, and then we multiply the negative 3 in. Remember the sign. So it's negative 3x, and this is a plus 6. Okay, don't make a mistake with your sign. Look at the number that you multiply in. Okay, so that's a 6. So let's simplify. On this side, I'm going to have negative 2x, negative 8. On the other side, I'm going to have negative 3x, and that looks like it's going to be a plus 10. Right, so x is on one side, negative 2x, that becomes a plus 3x. And on that side, I'm going to have 10 plus 8. So I get x is equal to 18. And that is my answer. Okay. If you didn't get it right, go back, do it again until you get it right. Okay, let's take a look at these questions. Now, these questions have got fractions in them. Okay. Now, when you see an equation of fractions, don't run away and go and hide in a corner somewhere. Just use the following steps. Write everything as fractions. So my very first step is going to be to sort that 1.5 out there. So I'm going to write this as 2x over 3 plus, that's 2 times 1, which is 2, plus 1, so that's 3 over 2 equal to x over 2. Remember that if you've got a 1.5, you multiply those two, and then you add it to that. Okay, so there's my fraction. Everything is written as fractions now. Now what you do is you get a lowest common multiple. So you look at all your denominators, and you find the smallest number that all of them can go into. And that number here is 6. Okay, and then you multiply every single term by 6. And I mean every single term, even if there's just a 1, it doesn't matter. Every single term gets multiplied by 6. Right, so step number 1 was, if you've got an equation of fractions, write everything as fractions. If there was a 6, you would write it as a 6 over 1. If there was a 2 1/4, you would write it as 9 over 4, and so on. Then you find the LCM, then you multiply with LCM. Now, the next step is cancel out. 3 goes into there twice. So we've got 2x times 2, so that's going to be 4x. Plus 2 goes into there 3 times. You have to cancel out the denominator, so it's not there anymore. And that is going to be 3 times 3, which is a 9, equal to 2 goes into there 3 times, so that's going to be 3x over there. Then you bring your x's to one side, so it's 4x minus 3x equal to negative 9, and in this case my x is just going to be equal to 9. Okay, so step number 1 is everything as fractions. Step number 2 is find the LCM. 4 is to cancel out, and then you solve for the unknown, or solve for x, or whatever it is. Okay, let's take a look at the top one here. There we go. Right, so what I need to do here is I need to write that as a fraction. I need to write this as a fraction. Now remember, something like 2 over 3a. 2 over 3 with the a next to it is the same as 2a over 3. We can show you now why. And 3a over 2 equal to, write that as a fraction, 2 over 1 minus 5a over 6. Okay, when you get something like 2 over 3a, it is exactly the same as 2 over 3 times a over 1. So it's always 2a over 3. You just take the a to the top. So in other words, if you get something like a half a, you can write it as a over 2. If the a is next to the fraction, you just take it to the top. Right, then we get an LCM. We've got a 3 and a 2 and a 1 and a 6 again, which means my LCM is going to be 6. So I'm going to multiply every single term by 6. And then I'm going to cancel out. 3 goes into there twice. So 2a times 2 is going to be 4a minus. 2 goes into there 3 times. So that's going to be 3a times 3, and that's 9a. There, nothing cancels out, so that's just going to be 12. And then minus here, the 6's are going to cancel out, and I get 5a. Right, then you're going to get a very strange answer. On the next, this side, you're going to get a negative 5a. If that 5a comes over, it's going to be plus 5a equal to 12. So you end up getting this. Okay? And when you get that, you know that 0 is not equal to 12. So this equation is wrong. This equation cannot be solved. It actually does not have a solution. So if you work out a whole equation, you get to the end, and the answer is 0 equal to 12 or 4 equal to 6, which is untrue. It means that there's no a that can satisfy this equation. So this is no solution. So if you ever get a question like this that cannot be solved, it means no solution. Right, okay. Now, these questions are extremely, extremely, extremely important. Okay, because they've got more than one term at the top there. So you have to be very careful now. So you're still going to do what we said. You're still going to write this as a 2 over 1. So everything is written as fractions now. Then you are going to get your LCM, which in this case is going to be 4. So you're going to multiply every single term by 4. Now I want to show you what you should not do. So think about whether you would have done the following, because it's wrong. Okay, you would have cancelled out the 2 and the 4, and that would have been a 2, so that would have been 2a minus. You would have cancelled out the 2 and the 4, and that would be a 2, and then you multiplied that with a plus 1, so you're going to get 2a plus 2. The moment you do that, you've done something wrong. Because remember, there's a negative at the front here, and we've spoken about this. If there's a negative at the front there, it means that it belongs to the whole term. Okay? So instead of doing this, I need to multiply the bracket by 2. Keep it in the bracket first. So you get a plus 1. That minus must get multiplied into that. Okay, so If you come across an equation and at the top you've got more than one term, put it in brackets, especially if it's got a negative in front of it. And if I was setting up your examination paper, I would give you one like this. I would put a negative at the front there, and I would not put brackets there around the a+1, and I would see if you realized that that negative actually belonged to the whole term. So it is extremely important that you remember to do this. Okay? Here I'm going to have a 2 times 4, nothing cancels out, so that's an 8, and the 4 cancels out to the 4, so that's just going to be a negative 3 times a minus 1. Right, now the moment we're there, we're back in familiar territory again, so it's going to be 2a, there the minus 2 gets multiplied in, so it's going to be negative 2a and negative 2. Remember to carry the negative through. So negative 2 times positive 1, it's negative 2. Don't subtract, don't say 8 minus 3. Okay, the 8 stays where it is, the negative 3 gets multiplied in, so it's negative 3a, and that's going to become a plus 3. Okay, please don't make a mistake like saying 8 minus 3 is 5 and then multiply the 5 in. Okay, that's not even an intelligent mistake. Want to make mistakes, at least make them intelligent. Okay, let's simplify this side. 2a minus 2a is nothing. So that's negative 2 on this side. That side we get negative 3a, and that's going to be plus 11. Okay, let's bring the 3a to this side, and the other side I'm going to have 11 plus 2. So I get 3a is equal to 13, and of course I'm going to divide both sides by 3, so I'm going to get a is equal to 13 over 3, or you can say that this is 4 and 1 over 3. Okay, and this is on standard. This type of question is a question that you can ask, it can be asked in the exam. So if you couldn't get it right the first time, go back and do it again. If you still don't get it right, go back and do it again. Don't just look at it and think that you can do it. Mechanics, 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 mechanics. Remember. Okay, the last fraction equation is this one here. And now, of course, because you've learned your lesson, you know that the very first thing that you're going to do is you're going to put this in brackets, because that negative belongs to the whole term there. So let's write everything as fractions. So I'm going to get 4 over 1 minus, I'm going to keep this in brackets, 1 minus 2x over 3. Because of that negative at the front, this is 1 over 1 plus, and that's going to be 3, 1 plus x over 2. Right, LCM time. You've got a 1, you've got a 3, you've got a 1 and a 2, so that means I'm multiplying by 6 every single term. Now remember, keep it in brackets first. So nothing cancels out here, so that's 24 minus 3 goes into there twice, so it's 2 times the bracket. You can skip this step as long as you remember that that negative still needs to get multiplied in there. Okay. On the other side, you're going to get 6 plus, now here, 2 goes into 6 3 times. So what I'm going to do there is I'm going to multiply that 3 with this 3 first. So that's 9, and then this is 1 plus x. Always do that first. Okay, 24 stays here. Don't say 24 minus 2 is 22. Okay, multiply the minus 2 in. The minus 2 in, so it's minus 2. This will become a plus 4x. Please don't make mistakes with your signs. If you see a minus 2, it means you have to multiply a minus 2 in. This side you're going to get 6. Let me just get this off my screen. And this is going to be plus, and you multiply the 9 in, so that's 9 plus 9x. Okay, let's simplify a bit. On this side, I'm going to have 4x plus 22. And on that side, I'm going to have 9x plus 15. Right, for a change, let's take the x's to the other side. So I'm going to have 9x here minus 4x. Doesn't matter which way you put the x's. And 22 minus 15. So I'm going to get 5x equal to 7. And now I need to divide by 5 there, divide by 5 over there. So I get x is equal to 7 over 5, which means that x is equal to 1 and 2/5. Okay, Do it again and again and again until you get it right. Okay. Right, these questions, I'm going to go through these questions quickly. They say there at the first one, subtract that one from this one, which means that this one is going to come first. If we have to subtract 8 from 10, we say 10 minus 8. So the one after the from comes first. So this is going to be 6 minus x squared plus 2x. So that's one. And from that one, I have to subtract negative 4x squared, negative 6x plus 4. So I keep them in brackets, okay, when I subtract them. When I add, I don't have to keep them in brackets because none of the signs are going to change. So this is going to be 6 minus x squared plus 2x, and there the minus gets multiplied in with all of them. So all the signs are going to change, plus 6x minus 4. And then minus x squared plus 4x squared, so that's going to be 3x squared. 2x plus a 6x is a plus 8x, and then 6 minus 4 is going to be a plus 2. Right, when I add, I really don't have to go and write it as bracket plus bracket. I can just add it. So it's going to be negative 2x squared plus 6x minus 4 plus 4 minus 2x squared plus x. So negative 2x squared and negative 2x squared gives me negative 4x squared. Then there's a 6x and a plus x, so that's plus 7x. And looks like that's going to be the same, because negative 4 plus 4 is going to give me nada, nothing, 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 nothing. Right. Okay, let's continue. If you want to take a break, you're more than welcome. This is just a little bit of a practice one again, because we've done this before. So what we do is we repeat some of the questions again and again and again. So we keep on going back to it, because that is the way that we're actually going to be repeating stuff and remembering stuff and going through the mechanics. Now you know that I need to do that over this, and I need to do that over this. But then you also know that that negative over there has got bearing on the whole term there. So you have to keep it in brackets. Okay, if you didn't remember that, you need to make a note of it now. So let's go on. So negative 12x squared divided by 4x. So that will be a negative. 12 divided by 4 will be a 3, and that will be x. Then negative 4x divided by negative 4x is going to be negative 1 minus, keep in brackets. The negative at the front still needs to be multiplied in. Right, then we've got 10x squared divided by 5x squared. 10 divided by 5 is 2. X squared divided by x, so there's an x left. Minus, and that's going to be 1. Now I get negative 3x, negative 1, and that's negative 2x, and that's going to be plus 1. And my answer is simply going to be negative 5x. Okay, big massive sum, but if you stick to your basics, you're not going to have a problem. Right, let's see what's waiting for us. Ratios. Okay, we're going to be taking a look at ratios. I'm just quickly going to take a 1 minute break. I'll be back in 1 minute. So just hang on there, go and stretch your legs, or go and get some coffee, or whatever. But a minute break, then we're going to continue. I don't want to stop the recording here. Right, we are back again. Got myself another cup of coffee. Going to need it. We've been going for about an hour and 30 minutes, and we're not through everything yet. But we're going to be taking our time, making sure that you understand everything. Okay, so if you take a look on your screen, you will see ratios. And I'm going to do certain questions at ratios. I'm going to be very selective. I'm not going to do everything in ratios. But your first type of question would be to take a number or whatever it is and to divide it into a certain ratio. Okay, now all of you have got your own way in which you're going to do this, and you're welcome to do it exactly like you want to. What I do is I add these, which is going to be 10. Okay, so that means that I find out how many parts I need to actually divide it into. So 2 plus 3 plus 5 is equal to 10. So what I do is I work out first the value of one of those parts. So I divide it by 10, and then it means it's going to be 120 Rand for every one part. Which means that if I've got 2 to 3 to 5, this one is going to be getting 2 times 120. This one is going to be getting 3 times 120. And this one is going to be getting 5 times 120. So this one is going to get 240. This one is going to get 360. And then that one is going to get 600. Okay? This is when you've got a certain amount and you have to share it between 3 or 4 or 5 or 6 or whatever it is in a certain ratio. Then you're always going to do it like this. Okay, work out the total number of parts, divide the amount or the number of sweets or the number of whatever it is by the number of parts, and find out what the value of one part is, and then you allocate it to the rest of it. Right, the second one. Now here you just have to be careful. We've got Oros and water is mixed in a ratio 2 to 7. So that means if you're going to mix Oros, you're going to take two parts of Oros and 7 parts of water. So it's mixed in a ratio 2 to 7. You will see that on any cool drink where you've got concentrated syrup and you have to do it, dilute it 1 to 8 or 2 to 7 or whatever the case may be. Okay. Then they say here, if 49 liters of water is used, okay, now remember that this side is your Oros, and that side is your water. Now they're telling you that if 49 liters of water is used, how many liters of Oros are going to be needed? Now you have to be careful now. Remember in the previous question, they gave you a value that you had to distribute among certain people or according to a certain ratio. Here, they are giving you that side of it. Okay? So you've got a few ways in which you can do it. You know that to get from 7 to 49, all you have to do is multiply by 7, which means here you're going to multiply by 7 as well. Okay? Or another way to do it is, it's 49 liters of water, and water gets 7 parts. So work out the value per part. So that's going to be, let's do it over here. That's going to be 49 liters of water, and that's supposed to be getting 7 parts. So that is 7 liter per part. So 1 liter, whether it's Oros or water, 1 liter or 1 part is equal to 7 liters. And for Oros, we need 2 parts. So that's going to be 2 times 7 liters, and that's going to be 14 liters of Oros. So can you imagine making cool drink with 49 liters of water and 14 liters of Oros? Okay, but yeah, they didn't, the 49, they gave you that the 49 liters were your water. So that means your 7 parts is 49 liters. You had to work out exactly what one part was, and then you could allocate it to your OROS. Right. Now, I'm first going to make a hideous mistake here. Okay, and I want you to see if you can see what I'm doing. That is going to be such a hideous mistake. Now, 5 teachers can mark a grade's papers in 4 hours. Okay, so we've got 5 teachers. And 5 teachers can mark the whole grade's papers in 4 hours. Okay? Now, I think before we get to that, let me just quickly do something else. Insert page. There we go. Done. Let's go back. Let's do this one. Let's say that Pete works at a car wash. He gets, let's say, 1,200 Rand for 12 hours of work. How much will he get for, let's say, 5 hours of work? Okay, now listen very carefully. It makes sense that the more hours Pete works, the more he is going to get. Makes sense, no? Okay, so we know that he gets 1,200 Rand, and he gets that for 12 hours of work, which means we need to work out how much he's actually getting per hour, and that is $100 per hour. Not bad for washing cars. Okay, so what we do is we get it back to 1 hour. So we know that Pete is making 1,200 Rand in 12 hours. And that means that he's making 100 Rand for every single hour. So if we want to find out how much he's making in 5 hours, if this is 100 Rand that he's making per hour, all we have to do is multiply it by 5. And that means that in 5 hours, he's making 500 Rand. Okay, easy, pretty easy. So we work it back to 1 hour, and then from there on we can answer any question that they want us to answer. But what is important here is that Pete, the more he works, the more he gets. Okay, now I want you to keep that in mind when we go over to this one. Because if you're going to do the same here, you're going to do this. You're going to divide by 5 everywhere, because you want to figure out what one teacher is going to do. And if I divide by 5, it means one teacher is going to do this in 4/5 of an hour. Now I want you to think about that. Something is not right. Okay? Because if 5 teachers group together and they mark a grade's papers in 4 hours, is it going to take one teacher longer to mark it or less? It makes sense that it's going to take longer. Okay, it's going to take longer. So this is wrong. This is wrong. I can't do this way. Can't do that way. That is completely wrong. Because what this is telling me is that one teacher is going to mark the papers, the whole grade's papers, much quicker than 5 teachers would mark exactly the same number of papers. So I can't do this. I could do it in the previous question. Yeah. I could do it in the question where I had Pete. And that's not a problem. That I could do here. I could work out what 1 hour was and then just multiply it. But I can't do it in this case. And the reason I can't do it in this case is because my proportion or my relationship is inverse. In other words, if I've got 5 teachers marking papers in 4 hours, then 2 teachers are going to take longer to do it. So the more teachers I have, the less my time. Now remember in Pete's case, the more hours he worked, the more he got. So basically, if the one got more, the other one got more. So if the one increases, the other one increases. Okay, if he works less hours, then he's going to get less money. So the direction is the same, but here the direction is different, because if I'm going to increase the number of teachers, my number of hours is an inverse relationship. And whenever something like this happens, you look at the product of your man hours. So let's take a look. They told you that 5 teachers can do it in 4 hours. That means that we are talking about, let's say, 20 hours of work. Okay? So the product is 20. Now that product will remain the same. It's the same number of papers that are going to be marked. So if 5 teachers do it in 4 hours, that means that's 20 hours of work. So if we're talking about how long it's going to take 2 teachers to do it, then that is going to have to be 10 hours. The product remains the same. The product in this case is 20. So it's 20 hours of work. So if one person is going to do it, it's going to take 20 hours. If 2 people are going to do it, it's going to take 2 times 10 hours. If 4 people are going to do it, it's going to take 5 hours, and so on and so on and so on and so on. So that means that we know that 2 times 10 is equal to 20, which means that if only 2 teachers are going to mark this, it is going to take a total of 10 hours. And it's important to understand the difference between this one and the one that we had with Pete. Let's just get back to this. Let me give you another example. And I'm going to add another page here quickly. Right there, insert page. There we go. Let's get back. There we go. And let's say that we are digging a hole. Okay, for no apparent reason. Let's say that your teacher decided to teach you a little bit about volume, and the teacher's actually got you digging a hole, and in your class there are about 20 people. So we've got 20 students, and they're digging a certain hole, and they take 4 days to do it. Okay, this is a work-related problem. You're going to see this in your later grades as well. This is a work-related problem. It makes sense that if 20 students does it in 4 days, more students will do it in less days, or fewer students will do it in more days. So it's an inverse reaction that you've got there. The question is, how long will 2 students take to dig the hole? Right, now you've already figured out that this is not a Pete problem. Okay, Pete worked, the more hours he works, the more he gets. This is if you've got 20 students who are going to be digging this hole, and it's going to take them 4 days, then it means 2 students are going to take much longer to do it. Okay, so the product needs to remain the same. Now we've got 20 students doing it in 4 days. That means that my number of man hours, or whatever you want to call it, is 80 hours. Okay, so that means 2 students are going to do it in 40 days, because 20 times 4 is 80, and 2 times 40 is also 80. The product remains intact. So that means that if 2 students are going to do it, the poor things are going to be able to do it in 40 days. That's child labor for you. I can think of a few of you that I would like to get to dig a hole here on the school grounds. Nah, yeah. Okay, so that's ratio. I'm not going to do anything more at ratio. I'm going to take a look at finances. And at finances, you can see in green there, that is your simple interest formula. And then the exponential, where the n is outside and it's an exponent, that is your compound interest. Now, you know the difference between simple interest and compound interest. Compound interest grows quicker. because you actually get interest not just on your capital but also on your interest. So at the end of every year, the interest that you've earned get added to your capital, and then you earn interest on that. But not in the case of simple interest. Simple interest, you earn every single year, you earn the same amount of interest on your capital. That's it. You don't get interest on interest. Okay, so let's take a look at a question. If 2,000 Rand is invested for 6 years, what amount will be available if it's invested at, and the first one is 10% per annum, simple interest. Right, so we're going to use our simple interest formula, F equal to, and that's going to be P, that's the amount that I'm investing, and then this is going to be 1 plus my I, that's at 10%, so divided by 100, it's 0,1, and then I need to multiply by the number of years, which is 6 years. Right, and then I have to go and check what that is going to be. Let's see. Right, and that's going to be 3,200 Rand. Okay. What is important at this simple interest formula is that this is always your number of years. Okay, in your simple interest formula, never put in there months or quarters or whatever it is. You always put in years there. Right, then we go for 10% compound interest. So it's again 2,000, but then you're going to have 1 plus, and this is still going to be 0,1, but now the growth is much quicker. And if you're going to do that, 1.1 to the power 6, you are going to get 3, 5, 4, 3, and change. Okay, so you can see that the compound interest grows quicker than your simple interest. You just have to be able to use the formula. So if they say simple interest, use your simple interest formula. Say compound interest, use your compound interest formula. Okay, now remember that if you look at your compound interest formula there at the top, your compound interest formula is a formula. Einstein once said that compound interest is possibly the best thing for humankind, because nothing grows faster than compound interest. But that formula can be used for finances, but it can also be used for population growth or population decline and so on. So I can, for example, give you the population of a country, and I can tell you that that population is decreasing or increasing by a certain percentage, and you'll be able to use that formula to actually work out what that population will be in 20 years or 30 years' time and so on. The same for bacteria, or the number of rabbits on an island, or whatever the case may be. Anything that's increasing or decreasing at a certain rate is a compound interest formula application. So let's take a look at this one. Okay, now this doesn't have anything to do with money, okay? But this is a case where a population grows. And if a population grows at a certain percentage, you can use your compound interest formula to work the sum out. Okay, so let's take a look at it. They give us the following. Let's just make that nice and yellow. There are 5 million people. There are 5 million people in a city. The population of the city grows at a rate of 2% per year. How many people will be there after 20 years? Okay. Now, you can use your compound interest formula. So your compound interest formula is F equal to P 1 plus I to the power N. So let's see. There are 5 million people in that city. It is growing at a rate of 2%, that's 0,02, and we want to find out how many people there are in 20 years. Now, if it is growth, this plus stays a plus. If the population is decreasing, then this plus becomes a minus. Okay, that's the only thing you need to remember. Let's work this out. 1.02 to the 2, and multiply that by 5 million equal to, and then we get 7429736,98. Now you're going to ignore that, the decimal, because you can't get 0.98 of a person. Okay, if you've seen the Saw movies or Hacksaw or whatever, Saw, Chainsaw, and so on, you probably have an idea of how you can chop up a person to get 0.98 of a person. But this means that you're going to have 7429736 people at the end of 20 years. That's 7.4 million. Okay, so that's an increase of nearly 2.5 million in 20 years. Okay, what is important here is that you can use this for population growth and population decline. For population growth, that is a plus. The moment it starts decreasing, then you have got the following, for example. 5,000 people. 5,000 people in a town, the population decreases by 5%, and they want to know how many are left after 10 years. Okay, so all that happens now is that your population decreases, so this becomes 1 minus I to the power n. If it is 1 plus I, you're working out an increase. If it's 1 minus I, it's a decrease. So what do we do? Let's take a look. 5,000 people. It's increasing by 5%, so that's 0.05. And we want to know what's happening after 10 years. Okay, so easy peasy. Multiply that. There we go. Multiply that by 5,000. And we get 2993,68. And of course, that means 2993 people are going to be left in that town after 10 years. Okay, you can take a look at that and see what's cooking. The next thing we're going to do is a HP agreement. Okay, extremely important. HP stands for Hire Purchase Agreement. And hire purchase agreement is always simple interest. They don't even have to tell you. In this case, they're going to tell you that it's simple interest, but they don't have to, okay? Because the HP agreement is always simple interest. Okay, so what happens here? Let's say that you want to buy a bicycle. And the bicycle costs 14,000 Rand, okay? You decide to go to Game. Please don't go to Game to buy a bicycle, but let's say that you go to Game and you want to go and buy the bicycle, but you don't have the funds available to pay the 14,000 Rand for the bicycle, but you do have $1,000. So you go to Game, you put down $1,000 as a deposit, okay? That means that you still have to pay 13,000 Rand. Remember that the bicycle cost 14,000 bucks. You paid 1,000 Rand cash, which means you still have to pay 13,000. Then what happens is that 13,000 is there's interest that is being added to it by using your simple interest formula, and then a final amount that you need to pay, which is usually much higher than you would have paid originally. And then they give you a number of months in which you can actually pay the outstanding amount. Okay, so that's an HP agreement. Anything that you want to go and buy that you don't have money for which you need to put down a deposit, and then you pay a monthly installment, a monthly payment over 24 months or 36 months or 72 months. The same with a car as well. If I go and buy my car and I'm not going to buy it cash, then it's also going to be an HP agreement. I'm going to put down what I've got, and the rest I'm going to have to pay over 54 months or 48 months or 72 months. The moment that happens, it's an HP agreement. Okay, let's get cracking. Right. A lounge suite costs 24,000 Rand. They want a 10% deposit that you need to put down, and the rest is financed over 24 months at a simple interest rate of 6% per annum. Okay? Number one, they want the deposit. Number two, they want the outstanding amount, and so on. Let's work out the deposit first. Now, the deposit, they said, is 10% of the cost. So your deposit is going to be 10% of 24,000 Rand, which means you're going to put down 2,400 Rand as a deposit. Okay? That's your deposit. So that is put down. Ooh. That is put down in cash, and it's paid to them, and it is not going to be added interest to. Okay, so the outstanding amount, so it costs 24,000 bucks, but you've paid 2,400 Rand already, which means you still owe 21,600 Rand. So that's the amount that you still need to pay. Okay? That's the amount that you still need to pay. Let me just see if I've got a page at the back here. Yes, I do. It's gone, yeah. Okay, so we've worked out the deposit, and we found the deposit was 2,400 Rand. And now we find out what the amount left is. That's 21,600. Okay, but you're not going to get to just pay that back. Oh, no. They're going to add interest to this. And that interest is going to be 6% per annum. So the interest is 6% per annum, simple interest. Okay, so you're going to use your simple interest formula. And you're going to take the 21,600 Rand, and you're going to add 6% interest. Now, what is important here is that you put the number of years in here. I cannot tell you how important it is that you remember that. At a simple interest formula, you never ever put number of months in there. Remember that they said that we're going to have 24 months to pay this. Okay? So if we've got 24 months to pay it, that means 2 years. Don't go and put 24 in here. Here, you only put your number of years. Always. Okay? So if you go and work this out, then you're going to get 6 multiply 21. 24,192. So that means you're going to pay 24,192. Okay, so that's nearly 3,000 Rand more than you would have paid for it. So that means nearly 3,000 Rand interest goes to the bank. Okay, so this is your total amount that you owe, 24,192. You're going to divide this by 24 because you've got 24 months to pay. And if you divide this by 24, it means you are going to pay per month, you're going to pay 1,006 is your payment. We also call it an installment. Okay. So that's your question. So there is the total amount that you owe. There's the total amount that you owe. Oops. There's the total amount that you owe. You divide it by 24, and that gives you what you're going to pay per for an installment. Then they also ask us about your interest. If you take a look at the previous question, in the previous question they asked you there at number 4, the total interest paid. Now the total interest paid is going to be the difference between, let's see where we are. The total interest paid is going to be the difference between that amount and this amount before interest was added. Okay, remember the 21,600, that was before interest was added, and when interest was added, it was 24,192. So if you take 24,192 and you subtract the 21,600, you're going to get your interest that was earned. So it's going to be 24,192, 24,192 minus 21,600. And that means that your interest was 2,592. That's your interest. Okay, so look out for this question. HP agreement. Chances are that you will get an HP agreement. I would definitely have asked an HP agreement. So it's your deposit first. Then you find out what is left, what you need to pay. After that, you add interest, this using the simple interest formula. Then you get the total amount that you need to pay. And then you divide that by the number of months that you've got to pay. And that gives you your installment or your monthly payment. Okay. And remember that your interest is just the difference between your amount before you use the simple interest formula and after. But remember that at a simple interest formula, you only use the number of years. You do not use the number of months. Okay, I think that is done. So we're going to get to the last bit now, which is number patterns. And this is really the last thing that we're going to do, I think. So we're nearly there, so just hang in. I think with number patterns, there are 3 number patterns that you should be able to recognize immediately. And those number patterns are 1, 4, 9, 16. Those are just the squares. So that's a 1 square, that's a 2 square, that's a 3 squared, and that's a 4 squared, and so on. So your general term is going to be n squared. Okay, so that's one that you can recognize there. And the same with this one. This is your cube. So that's 1 to the power 3, that's 2 to the power 3, that's 3 to the power 3. So my general term there is going to be n to the power 3. Okay, so look out for 1, 4, 9, 16 or 1, 8, 27 and so on. And if you see it, you already know you're busy with squares, you're busy with cubes. And then, of course, this one is your Fibonacci. And Fibonacci, if you add this one and this one, it's going to give you that one. If you're going to be adding the previous 2, that's supposed to be a 3 there. 2 plus 3. That, if you add that, it's going to give you a 5. If you add that, it's going to give you an 8. Okay. So what is important there is if you see a 1, 1, 2, any sequence starting with a 1, 1, 2, 3, then you know you're busy with Fibonacci. Then you know how to get the next and the next and the next one. Okay. So those number patterns you need to know. So let's get to what it is that we're going to do. So you are going to be asked number patterns in one of 2 ways. Either they're going to give you the number pattern and ask you some questions on it, or they're going to actually give you sketches, the first 3 sketches, and you have to look at the number of matches or the number of circles or the number of triangles or whatever it is. Now, the most important part of number patterns is that you need to get your general term. So if you take a look at this number pattern, you can see that a 3 is added every time, which means my general term will have a 3 in it. So I write it as 3n. Okay. If that difference everywhere is 6, then Tn is equal to 6n. Now, remember that my first term is 2. Okay. My first term is 2. So that means that if I make my n equal to a 1, I'm supposed to get 2. But that doesn't happen. If I make it a 1, I get a 3. So I don't get a 2. So what I do now is I just adjust my general term. So that becomes 3n minus 1. Okay. So to find a general term, what I do is I look at that difference, which is 3. I write Tn equal to 3n, and then I check it out. I test it with term number 1. So I put a 1 in there. But if I put a 1 in there, I get a 3. And it is supposed to be a 2. So now I adjust that general term by just putting a 1 at the back. So now you can work it out. If you want to work out T2, for example, T2 is going to be 3 times 2 minus 1, which is equal to 5. So this checks out. Okay, not a problem. So they can ask you to add the next 3 terms. They can ask you to get the general term, for example. Okay, there are 2 other questions that they can ask you as well. They can ask you, for example, what is the, now let's just quickly see here, what is the uh, 27, what is the 26th term? And then they can also ask it the other way around. Which term is 26? Now look at the difference between the two. If you look at the difference between the two, they say they're the 26th term, which means they know what n is. Okay, they know what n is. N is equal to 26. So you're going to work out T26. So what you do is you use your common term, which is Ta, which is Tn, which is Tn equal to 3n minus 1. And all you do is you just make your n equal to a 26. So that's 3 times 26 minus 1. And then you just have to work that out, and you're going to get whatever your term is going to be. Okay? And if you do that, you're going to get 77. Right. So the 26th term is 77. So they know what the value of n is. But look at the bottom one here. Which term is? So here, they haven't got a clue what n is. Okay, that means where you've got Tn equal to 3n minus 1, the 26 you're going to have to put in there, equal to 3n minus 1. Because you have to solve for n. They don't know what n is. So you have to solve for n. And it's very important to see the difference between the 2 questions. Okay, so what is the 26th term? That means you work out T26. Which term is 26? You put 26 in the place of Tn. So you're going to work this out. Now you've got 3n, and that comes over, that's 27. And then you divide by 3, so you get n is going to be equal to 9. So the 9th term is going to be equal to 26. Okay, I think I've got another example like this on here. There we go. Yeah. Okay, so for this example, let's say that we've worked out. Now I haven't put the number pattern there, but let's say that for this we've worked out that the general term is Tn equal to 5n minus 2. Now they want us to find the 6th term. Okay, so that is purely going to be T6 is equal to 5 times 6 minus 2. And that's going to be 30 minus 2, and that's going to be 28. There, you're done. Okay? But here they ask you which term is 98. So here you have to be careful. Because which term is 98 means that they don't know what n is. So if you've got Tn equal to 5n, what was this, minus 2, you have to put the 98 in there. Because they don't know what n is. You have to solve n. So that's going to be 5n, the 2 comes over, this becomes 100, and then I divide by 5, and if I do that, if I divide by 5 in there, I get 20. So that means that my 20th term, in other words, my T20, is going to be equal to 98 if I go and work it out. And the difference between these 2 questions are very, very important to see. Okay. Let's see. This one, an example. If you take a look at this question here, you can see what happens is there's a negative 2 everywhere, which means that my Tn is going to have a negative 2n in it. Okay, now let's test it first. Remember that my term 1 is 16. So if I put in a 1 there, I'm supposed to get a 16. So minus 2 times 1 is equal to negative 2. And that is definitely not a 16. So to get a 16 there, it means I need to add a 18. So my general term becomes negative 2n plus 18. And the moment you've got your general term, you can work out anything from there. Okay, let's take a look at what happens when you get questions like this. Okay, so what we have here is, there's your term number 1. Oops. There's your term number 1, there's your term number 2, there's your term number 3. But look at the number of matches or the number of sticks that you've got there. In this one, we have got, let's do this in red. We've got 4 there, okay? And then here we've got, if you're going to work that out, 1, 2, 3, 4, 5, 6. There we've got 7, and there we've got 10. So what you've got is you've got a 3 that's added again, which means Tn is equal to 3n. Okay, so let's test it. Remember, the first term is supposed to be 4. So if I test T1 is equal to 3 times 1, it's equal to 3. But it's supposed to be equal to 4. So I'm going to adjust it. I'm just going to add a 1. So I'm going to get Tn is equal to 3n plus 1. And the moment I'm there, I have got my general term. And then I can go anywhere from there. So even if there are questions that has this kind of thing in it, you still do it exactly the same way. The same with this one as well. Now they can ask you the number of triangles, or they can ask you the number of lines. In this case, let's say that they ask us the number of lines. So that would be 3. 1, 2, 3, 4, 5. That would be 5. 1, 2, 3, 4, 5, 6. That would be 7. And you can already see what happens there. 2 and 2. So Tn is going to be equal to 2n. So let's test it with 1. That's 2 times 1, which is equal to 2. But it's not. I'm going to have to add a 1 there because I need to get 3. I need to get 3. So my general term is going to be 2n plus 1. And then I can go crazy and I can do whatever I want to from there. Okay. Guys, we're nearly done. We've got 3 slides, and the 3 slides are just practicing. Okay, just practicing. Nothing new. We're done with everything new. So it's only practicing. I'm going to take a quick 10 seconds just to drink some coffee. And then we're going to do these together. This is the whole way this was set up. We're going to repeat some questions again and again because that's how you become used to those questions. Okay, we're going to take these questions one at a time. And if I were you, what I would do is I would actually write it down and go and do it, and then come back and check whether I've done it correctly. Okay, so you need to do that now. You can actually pause and go and do the question, or you can continue listening. Now, I cannot multiply that minus 2 into the bracket because there's a 4 outside there. That 4 locks the bracket. I have to do that part first. Okay, so the negative 2 is just going to wait for me there. Now there's a negative to the power 4, so it automatically becomes a positive. Then we've got 2 to the power 4, which is 16. And then, of course, that 4 gets multiplied to the 3 and with a 2. So that's going to be a to the power 8 and b to the power 12. Okay, remember what is important here is that number gets raised to that power and it becomes 16. You don't multiply it. Now I can multiply minus 2n, so I get minus 32 a to the power 8 b to the power 12. And there's my final answer. Right, these two. The second one is not really a difficult one. All you have to do is just multiply that in. So you've got negative a squared that needs to be multiplied in with that term and with this term and with that term over there, every single term that's there. But the reason I put this down is because of all the negatives. Don't just multiply in a squared. Okay, so don't do minus a squared times minus 2a squared is going to be a positive 2a to the power 4. And then you forget about the negative from there. Okay, remember that negative whenever you multiply into the bracket. So negative a squared times negative 2a squared is 2a4. Then negative a squared times a negative 4a becomes a positive 4a cubed. And then a negative a squared times a negative 1 is a positive a squared. Okay. Right, and then this one, a little bit more difficult, but of course, you bright sparks know what you need to do here. You also know that there's a negative there, which means I need to put this in brackets because that negative belongs to the whole thing and still needs to be multiplied in. Okay, by this time, you should know that. So if you didn't know that, I want you to do this sum 5 times. Even if you get them right on the second try, I want you to do it 5 times so that you can remember it. So the negative 2 we're going to stay with there. Let's see what happens here. 2a divided by 2 is just going to be a minus. 4 divided by 2 is just going to be a 2 minus. Careful here. 6a divided by 3 is going to be 2a. Minus 9 divided by 3 is going to be a 3. Now I'm going to have inside a minus 2. Then the minus gets multiplied in. So it becomes minus 2a plus 6. So you're going to get negative 2. Let's simplify a bit here. A minus 2a is a minus a plus 4. And then I'm going to get negative 2 times negative a is 2a negative 8. And there's my answer. Okay, careful of this. Careful of that negative here at the front. Okay, rather do that in brackets with the negative at the front, and then you multiply the negative in. Right, 2 more slides. Look at this monster. Okay, and you're probably looking at this and thinking, oh my gosh, Mr. Smith, you've probably gone crazy. And I'm going to agree with you after this. Yeah, I think we've all gone crazy. But what I want to prove to you here is that if you stick to your basics and you work from the inside to the outside, even though the sum looks big and it looks demanding and it looks impressive, if you start nibbling away at it and you start getting in there and getting your hands dirty, it is going to be solved. But if you look at a question like this and you just leave it out and you don't try anything, then that's not really going to help you. So when you get a question like this, let's go back to basics. We work from the inside to the outside. Okay, so what we're going to do is we're going to keep that bracket. Okay, so let's figure out. Now this is a cube root. So I'm going to divide all the exponents by 3. But I'm going to take the cube root of 64, which is a 4. Then that will be a to the power 6 divided by 3 is a 2. B to the power 9 divided by 3 is a 3. And C to the power 3 divided by 3 is a 1. Okay, that wasn't too difficult. And then this is a square root. Square root of 64 is a 8. And now I'm going to take all of these and I'm going to divide it by 2. Forget about the 2 on the outside there. We'll get to that. Let's finish inside first. So we get a to the power 6 divided by 2 is 3. B to the power 8 divided by 2 is 4. C to the power 2. Now, I'm not done yet. Remember that we are going to simplify inside the bracket first. Nah? And we're not finished yet. So there's a 4 and an 8. So if you cancel that out, there's going to be a 2 left at the bottom. A squared, A3 at the bottom, so there will be an A left at the bottom. Look at your b's. You've got b cubed and b4, so there will be a b left at the bottom. C1 on top, C2 below, so you've got a C at the bottom. So at the top, you've only got a 1 left. Okay, now you cannot simplify it anymore from the inside. So now you square everything. The 1 squared is just a 1. The 2 squared becomes a 4. The A becomes squared, the B becomes squared, and the C becomes squared. And there is your final answer. So now if you look back at it, you can see that that sum was actually not that difficult. Okay? You just stick to basics. You start on the inside and you work outside. Okay, if you didn't get it done, go and do it again until you get it right. Because if it means that you're going to get a question in the exam that has got square roots or cube roots in it, you'll be able to do it. Okay, you need to increase the number of tools that you can use to do the questions. Do it again and again and again. Right, let's see. I think we've got one left. And that is this one, which is actually peanuts at this point in time. So you can take a look at that as well. Don't take 10 minus 2 and write it as 8 times the bracket. Okay, don't do that, please. Okay, reason is, but must. You have to do your brackets first. So we have to do this first, and that as well. Okay, if you take a look here, you can see that minus 3 and that minus 2 is going to be multiplied into the bracket. Okay, so let's take a look. 10 stays where it is. Then here, what I'm going to do is I'm going to multiply the minus 2 and the minus 3 first, because remember, those are kissing brackets, so there's a multiplication there. And minus 2 times minus 3 is a plus 6, and then a minus 2. There I'm going to multiply the minus 4 in. Be careful of your signs. Minus 4a, minus 4, and then minus 2. So here we get 10 plus, multiply the 6 in. So it's 6a minus 12. All the way through. Remember, with this one and with that one. And then minus 4a minus 4 minus 2. And then from here it should be easy, because you've got 6a minus 4a, which is 2a. And then 10 minus 12 is minus 2. That's minus 6. What is that? Minus 2. Minus 6 minus 2, so that's going to be minus 8. And there we go. Okay, and that is the end of that. So what I'm going to do is I'm quickly going to stop sharing. So just hang in there for a minute. Right, and then I'm just going to quickly look you in the eye again. Okay, so we've just been through 2 hours and 20 minutes of mathematics, which means that if you're going to do it the way that I've asked you to do it, this is probably going to take you 4 to 5 to 6 hours if you do it properly. It's your decision what you want to do. Do you want to invest the time and get the marks? Because I promise you, if you invest the time, you will get the marks. You're going to get marks that you probably didn't think that you're capable of. So it's time to start believing that you can actually do it and stop believing that you can't do it. Okay? So we've gone over how you need to do it now. Write the questions down, do the questions. Mechanics, mechanics, mechanics. Even if you just take this slideshow and you do this entire slideshow and you stop and you do the questions and you go back and you listen to the explanation, you come back and you do the questions, but do it again and again and again until you can get to the top of the question, to the bottom of the question yourself. Never trust anything that I explain and you look at it and think that you can do it. I promise you there are 20 things that you're not thinking about. I can't do that for you. I can sit here at 6 o'clock in the morning and I can record this for you. I can do whatever I want to until I'm blue in the face. Your parents can run around and scream at you and take your iPad or take your dog or take whatever, or they won't let you go and visit your girlfriend, your boyfriend, or whatever the case may be. But in the end, the only one who can do this is you. It's nobody else. It's just you. So from this point in time, you need to be positive, and there are a lot more that you can do. But even if you just go with the slideshow, you'll be fine. Remember that Mr. Jansen also did classes, and he also did very recently he did a grade 8 revision class. So go and look at that. Okay. But you have to prepare yourself for the mathematics examination. Don't think for a moment that there's an angel that's going to come down from heaven, or Harry Potter is going to come around and is going to wave his magic wand, and all of a sudden you'll be able to do mathematics. Unfortunately, it doesn't work that way. Mathematics is like all things in life. If you put in the effort, you're going to reap the rewards. So I really wish you well. I hope that you're going to do well. I hope that you're going to work very hard and that you're going to prove something to yourself and your parents. I hope that at the end of the day, that you actually surprise the living daylights out of all of us. That your parents are actually astonished by the marks that you're getting. And all it is a mind shift. That is all it is. It's a mind shift of getting to work. And I promise you, you're going to reach a tipping point in mathematics. Even if mathematics is a big thing for you now, you're going to get to a point where you're going to start getting things right. And the more you learn those little tools, the more things you're going to get right. Then you're going to start getting excited, believe it or not, excited about mathematics, I promise you. And the moment you get a little bit more excited, you're going to try a bit more. And then you're going to see that you're getting more and more right. And you're going to start believing in your ability to actually get it done. And then success is going to breed success. And before you know it, you're going to be not anxious about the paper. You're actually going to be looking forward to the paper because you have armed yourself with so many tools and so much knowledge, and you've really put in the work, and you've worked through everything, and you've worked through the mechanics, and you've practiced, that you are actually excited about going in and doing that examination paper and proving something to yourself. So I really hope it's going to go well in the examination. I'm currently in isolation, so I'm not going to be at school this week because I had contact with a positive COVID patient. But I'm not positive. I don't have any symptoms or anything. It's just a precaution. You know how we do things at Glenwood. We are very, very careful, and we err on the side of caution. So I'm not going to be there this week. If you need me, you can contact me on Teams. I will be available during the week. If you want to ask me questions, I can quickly link up with you and do the question for you. Okay. Please go into the supergroup, and on the supergroup, you will get the November revision. There are practice papers and so on that you can do. I would start with the sharp paper, and there's some other papers as well, but only look at the ones that I've highlighted. Okay, guys, all the best. I really hope it goes well. Okay, thank you. I'm going to sleep now. Bye-bye.